So we are starting 931. There are 3 sections left in Unit 9, and we are going to do, a quick flashback. In Chapter 6, you learn that the solution to a system of equations is a point, and it's the point that makes both equations true. So it's the place where 2 lines cross, and that point of intersection is the solution to a system of equations. Well, now we're going to look at system of inequalities. How can you represent these solutions, notice it's plural, on a graph? How many solutions can a system of inequalities have? Consider these questions as you learn how to graph a system of inequalities. Find your graphs from problem 958. So you had 2 graphs, and I'm going to put them up on the screen, and those graphs were here and here. And so those 2 individual inequalities had their own solution sets. And what we're looking at is, what is the solution to a system of equations? And so we're saying a system, of inequalities. So we're saying, what if we graphed both of them on the same coordinates and made a double overlapping section? So that double overlapping section is where your solutions will lie. So what we're going to do on the actual notes sheet is we're going to graph that system of inequalities. So first, we've got y is less than negative x plus 5, 1, 2, 3, 4, 5 for the intercept, down 1, right 1, and we've got our negative 1 slope, and that one is less than or equal to. So we're going to do a solid line, and we're going to graph less than or lower than the line that we drew. Then we're going to do a second one. Y is greater than 2/3 x minus 1. So our intercept, negative 1, up 2, right 1, 2, 3, up 2, right 1, 2, kind of goes off. So instead of that, let's go back to the first point, down 2, left 1, 2, 3. And it is greater than. So this one is going to be dashed. And we're going to go up or above. So the double overlapping region is where you have that hashtag sort of cross-hatching. Which points are solutions to this system? That is, which points make both the inequalities true? So you would say anything that's in the double overlapping region, or you can say it's got the double overlapping region. So for example, 0, 0 would be a solution because it's in both the red overlapping and the blue overlapping sections. Verify your solution region from part B algebraically by substituting coordinates. So let's say we're going to pick 0, 0. So if we are checking 0, is it less than or equal to negative 0 plus 5? Is 0 less than or equal to 5? And we would say yes, clearly we can't have a negative 0. Is 0 greater than 2/3 times 0 minus 1? Is 0 greater than 0 take away 1? Yes, 0 is in fact greater than negative 1, so that works as well. We have to check it twice when it asks us to check algebraically because it has to satisfy both of the inequalities. Draw a graph of the region satisfying both inequalities below, then test points to determine the region that makes both inequalities true. So if we go with y is less than x plus 2, our intercept is 2 and our slope is 1. So that's an easy slope to draw, rise 1 over 1. And it's dashed because it is greater than and does not have the equal to. And it is less than, so we go down. All right, and the second one, y is less than or equal to 10. So 10 is our intercept. And the slope is negative 3/4, remembering that the coefficient for the x is our slope. So down 1, 2, 3 over 1, 2, 3, 4. Down 1, 2, 3, 1, 2, 3, 4. That's enough to get me to the edges. And that one is going to be solid because of the equal to. And it's less than or equal to. So I'm going to shade down or below that line. So the double overlapping region is sort of this lower section, I guess you could call it. And it says test points to determine the region that make both inequalities true. So let's say we're going to test a point like 2, 2. I actually really like testing coordinates that have double numbers because it makes it easy to substitute them. So the green one was the first one. Is 2 less than 2 plus 2? Yes, 2 is less than 4. Is 2 less than or equal to 10 minus 3/4 times 2? Is 10 less than or equal to 10 take away 6/4? And that's kind of 1.5. So yes, 10 is less than or equal to 8.5. Also true. So my point is in the double overlapping region, and it made both inequalities true when I substituted it. All right, so now we get into the interesting stuff. When graphing the system of inequalities below, Reina started with the boundary graph of each constraint shown at the right. So the dashed linear equation will go with y is greater than negative 2x. Why is it dashed? Well, we know it says y is a line dashed while the exponential function is not. So the line, the linear equation, y is greater than negative 2x, linear, does not have the equal to segment. The y is less than or equal to 0.5 to the x minus 6 does. And that's why that one is solid, or the curve is solid. So when we go to graph these, the linear one that's dashed is greater. So we're going to go up or above that line. And the one that is less than or equal to, which is the curve, we're going to go lower than the curve. And sometimes it helps to start on the right, the part that's a little bit more horizontal when you're thinking about lower. And so when it asks you for the double overlapping region, you've actually got this little chunk and this little chunk. Just remember that they go on infinitely, so they're actually much, much larger than they look on the graph, because you could keep drawing that graph and that section would keep getting wider and wider and wider. Look at Reina's graph at the right. How many possible solution regions are there? So this is interesting. You've got one region up here, which has only green, 2, 3, which are the yellow sections, 4, which is the section has no shading at all, and then 5, which is the red section. So there's actually 5 unique solution regions. Pick a point in each region and test how many regions make up the solution. Now, from our graph, we're able to say that there are 2 regions that make sense. If we want to test points, we would want to test something like -5, 15, or maybe even like -6, 15. So something like that should be in the solution set. And another one, if I wanted to go way over here, like 10, -10. 10, -10. Now, ways that you can test those. You can either test them algebraically. This one says, pick a point in each region and test it. Test it in the system of inequalities. So I might do something like y equals and 0.5. Nope, I'm not going to do it that way. I'll go to the regular screen. 0.5 to the, now if x is -6, and then subtract 6. So what I did was I plugged in -6. 15 is the y value. Is 15 less than or equal to 58? And we would say yes. The second time we do it, we're going to plug in, and I'm going to do second enter and just have it give me the equation again. And I'm going to go back to the -6 and put my 10 in there. 0.5 to the 10 minus 6. And I got -5.9. Is -10 less than or equal to the -5.9 that I got? Yes, it is. So both of those coordinates work for the nonlinear graph. The second one is y greater than -2 times x. So is 15 greater than or equal to -2 times -6, which is 12? Yes. Is -10 greater than -2 times 10, which is -20? Yes. So they both work. And they both work, both points work for both equations, so they are 2 separate solution regions. How many regions make up the solution to the system? And there are 2 regions. Why is 0, 0 not a good point to test for this solution? Well, it's on a boundary line, and it happens to be on a dashed boundary line, which means it's not going to help us at all. It also doesn't appear to be in a solution. Oh my goodness, boundary. On a dashed boundary line, nonetheless, which makes it useless. All right. How does changing the inequality symbol affect the solution to the graph? Notice that each system of inequalities below uses the same boundary graphs as Raina's graph from problem 697. However, notice this time the constraints are slightly altered. So on each one of these, we've changed either the greater than, the less than, which one has which symbol. And so when we're looking for an overlapping region, just that slight bit of change makes a huge difference as to the solution to the overall system. So the first one has the curve greater than or equal to the curve. So if we want to go with greater than or equal to the curve, we're up here. And then the second one, which is greater than the dashed linear section. Remember, we got to go all the way to that dashed line. The double overlapping region is going to be above the curve and also above the linear part as well. And it's going to go right up to that dashed segment. Notice the dashed part isn't going to be included. And if we wanted to test a good coordinate for this one, we might test something like 5, 5. Because 5, 5 should be a solution to both regions. Again, 0, 0 going to be a bad choice because it's on a dashed segment. Next one on B, if we are going to first look at the curve and it's greater than or equal to the curve, then we're going to go, same as we did on the last one, up above the curve. But then less than the linear would be down or below the linear segment, which would give us an overlap of this tiny little section that is between the curve and the line. Last but not least, if we go less than or equal to the curve, and that would be down here, we want to cover as much of the graph as we can. So you want to go as far to the left, as far to the right, cover as much as you can. And then the second one is also less than the line. And so that one, it's going to be a little harder to see the double overlap. We kind of run along the line and then we run along the curve and then we run along the line again, because you've got to look for both, in my case, the green and the red. And so it's always got to be below both parts. Now, I really like 969. I think this is a really interesting question. It says the United Nations asked every nation to write constraints that best approximate its country's shape. The UN thinks this will help find each country's area. So if we can make some sort of polygon that's close to the shape of a country, we can get an estimate of its square miles. Honduras sent in its constraints, but some of the information is unreadable. With your team, determine the missing parts of the inequalities and write them on the paper. So what we want to do is we want to go through and sort of do like a process of elimination. Which one of those inequalities goes with which piece on the graph so that we can figure out whether it's greater than, less than, or equal to. Now, the easiest one to start with is that horizontal segment, because that horizontal segment crosses the y-axis and you can see that it's down, it's shading below in order to get to a shaded region. And the only one on there that has no x's and no y's, it only has a number, is this one right here with the 2. And so we would complete that by saying it's crossing the y-axis. Y has to be less than or equal to 2 because it is a solid line and the shading is below it. Next, we've got one line here that has a y-intercept of 3. And I can see that there's one here with an intercept of plus 3. So I'm going to make that line, I think it is that equation. Also has a slope of positive 1, and this has an x with no coordinate in front of it. And it is shading. It's hard to tell, right, with my yellow highlighter, but it is also below. And so that would be a less than or equal to sign as well, because it is below and it is a solid line. Next, we could go with the line that has a positive 4 as the intercept. This one is also below. And so the one with a plus 4 would be this one. It also has a negative slope, so that would imply that we've chosen the correct one. And that would be a less than or equal to, because it is below and it is solid. So now the last two that we have remaining are shading above. So they both have an intercept here of -1, so that doesn't help anything. But if we go with this one has a positive slope going up to the right, which makes it the one with the positive 1/2 x minus, we'd have to put in the intercept of -1, so that would be -1. It is greater than or equal to, and that's good because the shading is above that line. Last but not least, the one that has not been shaded yet, we're going to color that one and say this one has a negative slope. It also has an intercept of -1. Some people might have pegged this one at the very, very beginning, and it is shaded above. And so that one's going to be a greater than or equal to because it also has a solid line, and we shaded up, negative slope, -1 intercept, and so it fits. All right. Hopefully that makes sense why we have this one region that fits all 5 of the constraints, and it is estimating the area of that country.